Welcome back to the Ahmed body. So we run the simulation, I hope things are clear. So now let's redo the mesh, but instead of doing now the quartz mesh, let's move to the next one just to show you well now what we added there. So basically, and we go here and here. So the difference in this one, I just want to show you. No, it's will Okay, let me delete this one. You don't need this one. That I just want to show off a little bit that added the letters and the logo there just to show you. So basically, those surfaces I exported as STL. So you access there, so that export everything STL, and then you can use it here. So this one will read V1 snappyHexMesh V1, and basically the only difference, let me put here false. I don't want to generate a boundary layer. And you're reading all your entities you choose is you want to use the single STL or the one assemblable with different parts. Be careful also, I forgot to mention that in the previous video that when you assemble in this case that there are watertight, your normals are okay, but you have to be very, very careful that the bodies, the parts needs to be perfectly matching. Okay, it cannot be a gap or they cannot be interpenetrating. So basically, you should fulfill that requirement. If you are, for instance, you split this one not using a plane there is no problem. But just to remind you that you should fulfill that requirements. So here you read the letters and the logo. Okay, now in OBJ format, then a lot of stuff. Here I put a lot of back medicine, let's say. So a lot of things there. Then the feature edges, the image, then the support, then LW. This is the letter. So see that I'm applying this letter, these refinement levels. So I'm using the levels, and this is a standard practice when it comes to image. I recommend you to use this keyword instead of level. Doesn't work very well. So I added all those refinement, and let's see here that we have H1, and let me go to H1 because this one I created manually. So just only to show you that you can create that file manually. It's really easy. Okay, so basically you give the coordinates, start 2 points, and how they are connected. Point 1 to point 0. 1 point connected to edge, connecting these edges. Okay, so from where do you get the coordinates? Just click there. You have the coordinates there. Click there. Click here. You have the coordinate there. So you put the coordinates here, and that's it. Okay, so in theory, having the geometry, you can do whatever you want. Now you can add this one. So I added manually there. I created manually the H1, then refinement surfaces, level 4 in all those district bodies. So here I'm using the multi-body, let's call it like that. So I'm reading the box STL. Inside one, I have the ground plane, the plane applying refinement in this way. So probably, as I mentioned, that you have to be careful that maybe you want a finer mesh at the ground level to avoid now because the Ahmed body is close to the ground. So look at that here, I'm putting a refinement of 4. I just want to mention that you need memory. Okay, so I'm not going to do it, but you have it there. In my case, I don't know. I haven't run in the computer where and save it, recording this video, but I'm quite sure that probably I will run out of memory. As I mentioned, snappyHexMesh it use a lot of memories, memory eager, so be careful about that. I'm about the distance there. This is the support. I added more refinement there. This point outside of the part, so external aerodynamics, ex standard values. Nothing new here, standard values. And as I mentioned, you can have also different parameters. So see here that this one has 3, 5, and then you can put local parameters. So you have a lot of control, okay? Contrary to what you might think that there is not a lot of control, you have a lot. What is missing is that GUI that also will prepare a video. In this case, using a GUI that I really love. It's a cloud-based GUI. Dicehot, probably you have seen it. And yeah, this is the case. Nothing else to point out. Everything prepared, and let's run the mesh. Okay, so at this point we have a mesh. Let's see the quality, if there are problems. So yeah, no problems, everything perfect. I didn't add the boundary layer. I just want to show you what we have here, Paraphone built in. And let me go load state. Okay, so be careful that this should point to the directory where you have. So let me put it there. And actually, let me save it as well. So you have it already. Okay, so what we have here is this, but now let me put, and there you go. Quite cool, now nice. So see what we have here, WD. I capture the letters and I use the edge refinement with distance. So very nice. Look at this edge I mentioned that I added there in that edge. And here we have our logo. So a little bit, just I mentioned just to show off that you can do a lot of stuff. See here that these edges are captured better there. So a lot of control we have. Very, very nice. So you just need to understand well the workflow. Don't get intimidated by all these keywords. Probably as you clean up the comments and so on, you will see that yeah, very standard. Okay, use default values. Like in commercial tools that they don't expose all these keywords, but then you can access and you will see very similarities, a lot of similarities, but then commercial, they give you default values. Here, OpenFOAM, they don't give you default values, or they give you something, but you never know. But what I'm giving you here are my default values that I have compared with many tools. I'm pretty much I trust in the values that I have. Okay, so this is it, what I wanted to show you here. Okay, so yeah, a new technique. We're moving here. We have done a lot. We have covered a lot. So the next videos, I would like to show you the same workflow using now Fluent Mesh, just to compare. So you will see it was much, much easier. You have more control. But yeah, as you have access to that tool, you can use Snappy, and as you can see, it's very powerful. So thank you. See you next video. Bye.